Okay, so hi there folks, we're now in our next video in the introduction to statistics, and in this video we're going to talk about sampling, okay, collection and organization of data. So though we're going to focus solely on sampling, but this chapter, by the way, is going to be called sampling, collection and organization of data. So let's first talk about sampling. So I have mentioned this during the first part of our or the first batch of videos that I have given that sampling is when you will be producing a sample out of the big population. So to give it a formal definition, so sampling is the process of selecting the subjects of the population to be included in the sample. So again, just a reminder or a throwback, a small n is what we call the sample of our study. The big N is the population. Again, the population is the target, your target population of your study, but you cannot always just get the population. Instead, you may opt to use the sample, okay, instead of the population, which is a subset of the population and should be a representative of the population. So there are four major reasons. Though there are lots of reasons more. There's a lot more reasons rather. So why we use a sample rather than population, and let me enumerate them one by one here. Number one, it's too costly to test the entire population. So if you have enough money, so why not? Okay, but again, it's too costly to test the entire population. Second is that it may be impossible to test the entire population. Okay, it may be seldom impossible, especially when your population will will have the whole country, the whole city, wherein everyone must be included, even though it's impossible to get their data. So seldom it's impossible to do that. Number three is that testing the entire population often produces error. Okay, so it often produces error. And number four, testing the population may be destructive. So example, if you're testing something in human beings, about the organs of human beings, you need to test everyone's everyone's organ for that, so it may be destructive. Okay, so just one example for that. So these are the four major reasons on why to use sample. Of course, there are far more reasons, like you don't have the manpower, you don't have enough energy to do that, you don't have enough time if your project or your thesis or study is time bound. So those are some reasons also. Just take note in sampling, take note, nota bene, it is extremely important, like I always emphasize, to choose a sample that is truly a representative of the population, so that the inferences, the conclusions derived from this sample can be generalized back to the population of interest. Okay, so this is fairly a simple statement, but it has general meanings, wherein your sample must be, again, a representative of your whole population. Since imagine this is your population here, the big circle, this is your sample here, this should represent the whole population, so that when you make generalizations, it will be reflected to the whole population. Indeed, this is what is happening in the whole population. Improper and biased sampling is the primary reason for often divergent and erroneous inferences. Okay, so that's some of the reasons. Okay, when we end up with some erroneous inferences. Okay, so this improper and biased sampling. Okay, so especially conducted in different polling groups and those things. Okay, now after this, let's talk about the types of sampling. Okay, so there's a lot of types of sampling in which we're going to discuss one by one in this video. We have two major types of sampling, which is called probability sampling. The other one is called the non-probability sampling. Okay, so let's talk about the first one. So probability sampling is a type of sampling in which each element of the population is given a chance, or seldom an equal chance, which is non-zero probability. Everyone has a chance to be in that sample, which makes it fair for everyone, right? Since everyone is part, for instance, your study will include everyone. So since everyone is part of that population, so why not include everyone in the sample? I mean everyone has an equal chance to be part of the sample, right? So this minimizes, if not eliminates, selection bias. Okay, this probability sampling does that. Okay, this is also ideal if generalization of results is important to your study. So if you want to generalize, okay, from a small population or a small subset that's a sample, you generalize it to the population. So this will be ideal. And inferential statistics procedures can be used for arriving at generalizations or conclusions about the population data. Okay, that is based on the sample data. Okay, so we'll discuss the types of probability sampling here. We have the simple random, systematic, the stratified random, the cluster, and then the multi-stage random sampling techniques. And these are, in some books, they are called sampling techniques. Okay, sampling techniques. Okay, now let's discuss them one by one. We'll start with the simple random. Okay, so the simple random, often in some books they call this lottery method or fishbowl method, but the proper name is simple random sampling, SRS. Each element here in the simple random sampling or simple random technique, each element of the population is given an equal chance, okay, of being included in the sample. Everyone has an equal chance of being included in the sample. So this is actually the foundation of all the probability sampling procedures. Okay, and this is the most basic probability sampling procedure, or the most basic sampling technique. Okay, now when will we use this? When will we use this? So we use this primarily, we have two, shall we say, conditions. Okay, we use this when the population is homogeneous, shall we say. So when we say homogeneous, so they are the same when it comes to characteristics, especially with the characteristics of the variable that you're looking forward to get or to gather. So they are homogeneous, and then a sampling frame is available. What is a sampling frame? It is a complete and updated list of the population. So that's what we call a sampling frame. So if the sampling frame is available and the population is homogeneous, so you may use this simple random sampling. Now, what is the procedure in doing such? One may think of a lottery method wherein you're going to write all their names, put it in a bag, write your names, put it in a piece of paper, cut all of them, okay, put it in a bag, in a fishbowl. That's why seldom it's called the fishbowl method, because you're putting in a fishbowl and then you're drawing lots, okay, until the number of n is achieved. So you may also use the random number generator, wherein a computer will give you a feedback of these are the numbers that you will take in your sample. So this is very random since the computer is using it and no one is. So it's also okay to use the random number generator. One can do and see such in Microsoft Excel. Okay, there's a random number generator there. Okay, so that's simple random. In our language, maybe we call this draw lots. Second is the systematic random sampling. So this systematic random sampling, it's very similar to the simple random, only that there's a system from the word itself, systematic. So we are selecting every kth element of the population. So there is an interval, shall we say, that every kth element of the population is being selected. Okay, so this is very, very similar to the random or simple random. So when will we use this? We will use this when the population is homogeneous and we know that there is no pattern or suspicion of a pattern in the frame or of the geographical layout. Okay, there's no trend, there's no pattern. And also we can use this when the sampling frame is also available. That is a complete and updated list of the population. So to illustrate what we mean or what we do in the simple random sampling, since we only say that every kth element of the population is being selected, this is how it does. So for example, let your k be equal to 3, meaning every third person is being selected in the population. So you must have a list of your population, and then for example, you will start in this person here. Let me draw a stick figure of a man, and then you chose this person. So since your k is 3, therefore every third person will be chosen. For instance, we can see here that 1, 2, 3, this person is chosen or part of the sample because he or she is the third person. This is a he. Okay. And then 1, 2, 3, this next person is being chosen because he is the third person. And then 1, 2, 3, the next will be chosen here. And then so on. So that's how you do the systematic random sampling. Okay, again, this must be done when you are sure that there's no pattern or trend in the list. Now, in the systematic random sampling, there's a procedure that we will be taking up on how to get the values of k, since k is the one that determines the number of intervals. So that's pretty much one big important thing here in the systematic random sampling. So in determining the sampling interval, we call that the sampling interval k. We use this formula k is equal to population size over sample size, and it should be rounded to the nearest interval or the nearest integer, shall we say, the nearest whole number, integer. Identify the random start. Then after we identify the k, we must of course identify where we will start, because without that starting number, everything else will be a question mark when we will start. Okay, maybe selection bias is there. So we must identify a random start, r sub s, we'll call that a random start. And this random start must be somewhere between 1 to k. So if your k is 3, your random start will be 1 to either 1 or 2. If your random start is equal to, or if your sampling interval is 6, so you can have a value of your random start to be either 1, 2, 3, 4, or 5. Okay, so that's your random start. Now, next is you determine the number of elements to be included in the sample. So that is by the power of the identifying the sample size. So how do you do that? You first start with your random start. After that, you use the interval so that you can move to the next part of the sample. So what you'll do is you'll get the random start, add your first interval there. Okay, and then that will be your second sample, second part of the sample. Next is what you'll have is your random start plus twice your k, that is k plus k. So in essence, this looks like random start plus k plus k. So that is your second interval. And then here we have the next one is the random start plus 3k, that is in essence r sub s plus k plus k plus k. So that you are already on the third step on the interval. So that's how you determine the number of elements in your sample, in your sample size. Next, some error, sorry. Now, I'll give you an example. So for instance, we will let our population to be 10,100. Let's say these are individual people, human beings, and our n sample will be 150. So we will only need 150 out of the 10,000. So this is very much helpful, because instead of interviewing or surveying 10,100 people, we only need to survey 150. So we'll get the value of our k first. What's the value of our k? So k is equal to big N over small n. That's equal to 10,100. Oops, sorry, 100 over 150. So 10,100 over 150, let me get my calculator for that. 10,100 divided by 150, it's going to give me 67.333. So let's round it up to the nearest integer or nearest whole number. So the answer is 67. So meaning my k, therefore my k is equal to 67. So in my list of 10,100 people, I will choose every 67th person. So since we know now my k, so we need to find then the r sub s, the random start, which should be between 1 and k. Then the random start can be any number from 1 to 67, which is to be chosen randomly. For example, if we have taken a random start from, we will ask a friend or ask the computer, give me a random number from 1 to 67. So the computer answered 43. Thus, the 43rd in the sampling frame or in your updated list of your target population is the first to be included in the sample. Okay, so the 43rd. So if you have a list 1, 2, 3, 4, 5, blah, 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 the 43rd will be the first one to be selected as part of your sample. Now, after the 43rd, you must select the second. So the second is the 43rd plus your K, or this is where the every 67th person starts. Okay, so 43, you add the 67 there, which is your interval. The next one in which you will interview or survey is the 110th people or person. Then you add another 67 for that, and the next person that you will interview is 177, and I think you know what happens then. And then this continues on and on. Okay, so we can see the third is going to be random start plus k plus k. The fourth will be your random start plus 3k, k plus k plus k, and so on, and so on. This continues up until you reach 150. Up until you reach 150. Okay, so that's our systematic random sampling. Next up is our stratified random sampling. So this is about selecting random samples from mutually exclusive subpopulations. These subpopulations are what we call strata in this point of view. So this strata, okay, is very important, okay, in our stratified random sampling, since the name itself calls that. So when will we use this stratified random sampling? We will use this when the population is heterogeneous, but they can be subdivided into homogeneous strata. Okay, we must make sure that each strata are homogeneous. Okay, every strata, they have the same characteristics. It depends on our study. And the sampling frame, of course, must be available per stratum. Stratum is the singular, sorry. Stratum is a singular for strata. Okay, the plural of the word stratum is actually strata. Okay, the singular is stratum. This is the singular versus. Okay, so what's the procedure in making or in doing the stratified random sampling? What we'll do first is we need to determine the proportion of each stratum relative to the population. So in some books they will explain, or they will have this proportionate stratified random sampling and simple stratified random sampling, wherein in the simple there is an equal number of n that we will be taking up from each strata, but it will be very ideal that it will be proportionate. Okay, that's what we call proportionate stratified random sampling. So it should be proportion for each stratum. Okay, so that's it, the first step. Then we need to identify the stratum sample size using proportional allocation. This is again the proportionate stratified random sampling. And then select the samples from each stratum using either, after we get the number, we're only getting the numbers actually. After getting the numbers, your n per stratum, we will be making use of the simple or systematic random sampling to gather the data from each stratum. So to give you an example, for instance, we have this. Among 250 employees of a certain company, so there are 250 employees all in all, 182 are Filipinos, 51 are Japanese, 17 are Europeans. If we use proportional allocation to select a stratified random grievance committee of 15 employees only, how many employees must we take from each race? So again, we have the Filipinos, we have the Japanese, and we have the Europeans here. So how many races must be there for a 15 employee grievance committee? So let's do this. Let's have first our races, since we are taking up from each race. So let's have this. So let's do this again. Race 1 is Filipino, second is Japanese, third is Europeans. We have the N. We have a 182, 51, and 17. Overall, they are 250 here. And the percentage, let's do that again. 182 divided by 250, 72.8%. I believe this is 20.4%. and 17 divided by 250 is going to give us 6.8%. So adding them up, 72.8 plus 20.4 plus 6.8 is going to give us 100%. That's cool. That's great. Now we need to get how many ends do we need, or how many partitions of the race do we need if we only need 15 employees all in all. So actually this is your big N, not your small n. This is your population, right? We only need the n sub I. Okay, so we only need 15 of them, 15. So out of this 15, we multiply this 15 by 72.8%. So meaning, how many do we need? So let's do this. 15 times 72.8, or rather 15 times 0.728. So in the Filipinos, they need to have 10.92 of them. So there is no 0.92 human being. So let's approximate this or round this off to 11. We need 15, so multiply that to 20.4%. So 15 times 0.204, that's going to give us 3.06. That's going to be rounded up to 3, right? And then for the Europeans, we have 15 times 0.068. That's going to give us 1. 15 times 6.8%. That's going to give us 1.02, in which it will give me only 1. Okay, so 11 plus 3 is 14, plus 1 is going to give us 15, which is right on what we want in the stratified sampling. Okay, so as you can see, 15, we got it. Meaning in this allocation of races, 11 people must be Filipinos in this certain grievance committee, 3 must be Japanese, 1 must be European. Again, we do this so that there is a representative per stratum. Okay, so hopefully you got that on how to do the stratified random sampling. For the cluster random sampling, a cluster sampling is selecting clusters of elements rather than individual elements. So when you say cluster, it's like lumps or groups of elements. We're not going to get individual people to survey on, but if we're going to choose some certain geographical locations, usually we call this area sampling in some books, but it's not only limited to geographical locations. It may be some groups of like a section of class, what else, a group of companies and such. So we use this when natural groupings are evident in the population itself. When there is a natural groupings, okay, in the population, which is evident. So a sampling frame is not available. So if the sampling frame is not available, one can always resort in using the cluster sampling. So what's the procedure in doing so? So the procedure is, first you divide the population into clusters. That's your M. M means your total number of clusters. And then you randomly select small m clusters out of this big M clusters. So the big M clusters is the total number of clusters. Say for example, we have 25 clusters all in all, and then in each of these clusters there are a lot of individual samples. So say you want your small m to be only 5. So you choose 5 out of this big M, which is your total number of samples, randomly. And then when you choose this small m clusters, you must include all elements within that clusters to form your sample. So for instance, again, if there are 25 big M, in the big M, if there are 25 clusters, and then you randomly selected small m clusters, which is only 5, so in this 5 clusters that you have selected, there must be that, you must be sure that everyone is selected there. Everyone is going to be selected there. So that's how you do your cluster random sampling. Before we end here, I'll just have some remarks of comparing a stratum and a cluster. So although strata and clusters are both non-overlapping, they are mutually exclusive subsets of the population, they differ, only one differ will do, they differ in several ways. So number 1, in stratified sampling, the best survey results occur when the elements within each strata are internally homogeneous, which I said in the stratified random sampling part, in which each strata or each stratum must be homogeneous. However, with cluster sampling, the best results occur when elements within each clusters are internally heterogeneous. Wherein, uh, I mean, when you are sure that the clusters or each cluster are heterogeneous, and that is um, every group or every category, every variable is represented in each cluster. If you're sure about that, so it's okay to do cluster sampling since they are heterogeneous. So I think the best picture to depict that is these or are these. So first here, this is a strata here. This is a stratum rather, and this is also one stratum. Okay, so we characterize them as in sex as a noun. Okay, so these are all women here, and these are all men here. So again, in the stratified sampling, we need to choose still our n using simple random or systematic random. So this is this is the strata, wherein we divide them into homogeneous subgroups. In a cluster, if we are sure that all variables or all characteristics are taken into consideration, that is, they are heterogeneous, so we may use cluster. For instance, here in the presence in the, I don't know what place is this, United States, I think. So we have here how many? 32. Our big M is 32. There are 32 clusters, and we are only to choose 3. Okay, we are doing this because we are sure that in each cluster they are heterogeneous. So we chose cluster number 5, number 16, and number 28. And if we choose our small m clusters, we must be sure that all of them are heterogeneous. Okay, so meaning all characteristics of the variables are represented. Okay, and we also, of course, we must interview everyone in each of these 3 clusters here. Okay, so that's the difference of a strata versus clusters. Lastly, we have here the multi-stage random sampling. Some books call this as making use of different or combining different random sampling techniques. But here we'll call this is just a repeated cluster sampling. Okay, again, so this is just a repeated cluster sampling. Okay, so I think we have talked some time about the probability sampling, so I think it is best to end the video. In the next video, we're going to talk about the non-probability sampling. Okay, so thank you very much for watching. I hope that you would like and also subscribe, and see you soon in the next video. Okay, thank you again.